So for Unit 5, we're working with quadratic some more, so we're still looking at quadratic equations. Today we're going to be looking at roots, radical expressions, and solving by square root. So we actually are going to be doing 3 different things in these notes. So we have a lot of examples, but it's nothing that we can't handle. So example 1 is starting us off. We have the square root of 75. Now, is 75 a perfect square? Can I take the square root of that?
No.
No. But I can take the square root of part of it. So the way that I do these problems is I take what's on the inside and I break it down as much as possible. So I do a factor tree. So what are 2 numbers that 75 break down to? 25 and 3. And then 25 breaks down to 5 and 5. So this is the same as the square root of 3 times 5 to the 2nd power. This is called the prime factorization of 75. So we're writing it out in terms of prime numbers only. Now, square root, which we will learn, means that we're looking for pairs of numbers, right? What number times itself? So, can I take the square root of 3? No, but can I take the square root of 5 squared? Yeah, what's the square root of 5 squared? Well, 5 squared is 25, and what's the square root of 25? 5. So we can take 5 on the outside, but the square root of 3 is left on the inside. So this would be 5 square root of 3. So we can only pull out perfect squares. Everything that's not a perfect square has to stay on the inside. And the reason why I write it out as 5 squared is because this is going to help us later on when we start taking cube roots and 4th roots and bigger roots than just a square root. Okay, so writing out the exponent is going to help us later on. Okay, example 2. Square root of 450. So let's try and break 450 down. How can I break up 450? 45 and 10 works. Does 45 break down even more? Yeah, to what? 9 and 5. And 9 breaks down to? 3 and 3. What about 10? 5 and 2. So this is the same as the square root, and I always list everything in order from smallest to biggest. So we have 2 times 3 times 3, which gives me 3 squared, and we have 2 5, so that's times 5 squared. So our prime factors are what are at the end of the branches that we cannot break up anymore. Okay, so can I take the square root of 2? No. Can I take the square root of 3 squared? Yes, that's going to give me 3 times square root of 5 squared. 5. Square root 2. Obviously, this can be simplified a little bit more, right? What's 3 times 5 give me? So the answer is 15 root 2. What happens if I have a number already outside the radical? So 7 times the square root of 24. You're right. Yeah, we just multiply by whatever we pull out. So will you guys do example 3 for me? How does 24 break down, guys? 6 and 4. 6 breaks down to 2 and 3. And 4 breaks down to 2 and 2. So this is the same as 7 root 2 to the what power? 3rd times 3. Okay, can I take the square root of 2 to the 3rd?
Yep.
No, but can I take the square root of part of it?
No.
Yeah, there's a 2 squared, right? So we have 7 times 2. But what happens to that extra 2? Stays on the inside, so 2 times 3. So then what's my answer going to be? 14 root 6. Okay? So 2 to the third is not an even number. It's not divisible by 2, so one of them had to stay on the inside because we are only looking for pairs of numbers. Make sense? Okay. Example 4. What happens when we're multiplying two radicals? So we have 8 root 21 times 2 root 35. Okay, now I like to think of radicals as similar to like terms. We can only add them if they're exactly the same, but we can always multiply any terms together. So what I'm going to do is first let's break these down. So 21 breaks down to what? 7 and 3, and 35 breaks down to 7 and 5. So before we do anything, let's just rewrite it. So this is going to give me 8 square root 7 times 3 times 2 square root 7 times 5. Oh, I didn't put them in numerical order. So that's going to give me 8 times 2 square root. So we multiply the outsides, and then we multiply the inside. So that's going to be 3 times 5 times 7 to the second power. So we multiply the outside, and then we multiply the inside. So that's going to give me 16 times, what's the square root of 7 squared? 7. 3 times 5 stays inside. 16 times 7, did anybody get that yet? 112? 112? 112 root 50. And that's your answer. Okay, let's look at what happens when we have radicals with fractions. One thing we need to remember, when we have fractions with radicals in them, there are no roots allowed in the denominator. So absolutely no roots in the denominator. Big no-no. So if you ever see a root in the denominator, we're going to do what's called rationalizing the denominator. 2 steps. First, we're going to multiply the numerator and denominator by the denominator. So whatever's at the bottom, we're going to multiply top and bottom by that same number. And then we're going to simplify. Okay, so let's look at an example of that. Example 5. Root 9 over root 7. So this is what a problem will look like. Sometimes you might be doing a problem and you get an answer that looks like this. Never, ever, ever is a root allowed in the denominator, so we have to get rid of it. So step 1 tells us we multiply top and bottom by the denominator. So that means I'm going to multiply by root 7 on top and on bottom. Does anybody have an idea why we have to do top and bottom by the same thing? To get rid of it. Well, what's root 7 over root 7? What does that reduce to? 1. If I'm just multiplying by 1, did that change the value of the fraction at all? We're just changing where the radical is going, but we're not changing the value at all. So multiplying fractions, we just multiply straight across. And this is what I mean. We can multiply root 9 times root 7, so that's going to give me root 63 over, what's root 7 times root 7? 7. I'm going to write it out first this one time. That gives me root 49. But square root of 49 is 7. Okay? You can go straight to 7. You don't have to write the root 49. I just want you to have it written down once so you remember. 63, how does that break down? 9 and 7. And 9 is 3 and 3. So this is the square root of 3 squared times 7. So that gives me an answer of 3 root 7 over 7. And that's your answer. So we don't have a radical in the denominator anymore, so that's our answer. You do need to simplify all of the way. I see very many times root 63 over 7, and that's my answer. Please make sure you're simplifying it as much as possible. we want the smallest number possible inside the square root. Okay, so we don't want any perfect squares inside of there. So will you guys try example 6 on your own then? Root 20 over root 9. Okay, so we have a square root 9 in the denominator, so that means I'm going to need to multiply top and bottom by square root of 9, which gives me square root of 180 over root 9 times root 9, 9. 180 breaks down to 20 and 9. 9 is 3 and 3. 20 is 5 and 4, and that's 2 and 2. So that's going to give me 2 squared times 3 squared times 5. Is that what you guys got? Okay. All over 9. Okay, square root of 2 squared is 2 times square root of 3 squared, 3, square root 5, all over 9. So that's going to give me 6 root 5, all over 9. Am I done? Why not? You can reduce. 6 and 9 both reduced by what?
3.
By 3. So that's going to give me 2 root 5 over 3. Okay, yes, I'm aware that the square root of 9 is 3, and if you realize that at first, we could have gone straight to 3 on the bottom and 2 root 5 on top. I wanted to do it the long way just because I wanted to show you guys an example of when we can reduce right here. Sometimes you will still have to reduce after you're done. So you just want to make sure that you're looking at the problem, asking yourself, can I reduce any more? 6 and 9 are both whole numbers. They're integers. So you can reduce these two, but we cannot reduce anything by whatever's inside of the square root because those are not integers. Okay, they are stuck inside the square root because we can't get it out as an integer. So we leave it there as shorthand. Okay, like if I were to put square root of 5 in my calculator, that's going to give me 2.23606. Oh, there's a glare. 67978, and it goes on for quite a long time. So the square root of 5 we leave written as this to give us a more exact answer than having to put out the decimal. Okay, so square root of 5 is not an integer. We cannot simplify it with whatever's in the denominator. Okay, square roots are by themselves. Does that make sense? So you can only square or reduce the integers, the whole numbers. Okay? Alright, so then what would happen, now we're going to look at what happens when there's a square root in the denominator, but it's not by itself. It's being added or subtracted with something. So we're going to have to use what we call the conjugate. So this is a brand new vocabulary term. But it's pretty simple to remember. The conjugate of A plus root B is A minus root B. So it's basically exactly the same, but we change the sign. Okay? So conjugate means that we change the middle sign. If it's addition originally, we change it to a negative. If it's subtraction originally, we change it to addition. Okay? So everything's the same except for the sign. So how do we rationalize using the conjugate? Same basic steps. We're going to multiply the numerator and denominator by the conjugate of the denominator. So we're still only working with the denominator. But there's going to be some multiplication, so we're going to have to use FOIL or box method, whichever one you prefer. And then we'll be able to simplify. Alright, so example 7. We have 7 over 3 plus root 5. So I still have a root in the denominator, but this time it's being added. So I can't just multiply by square root of 5. I need to change that entire denominator. So I'm going to multiply by the conjugate. If I have 3 plus root 5, what would the conjugate of that be? 3 minus root 5. So same kind of idea, we have to multiply top and bottom by the same thing because those end up reducing down to 1, so it's not actually changing the value, it's just kind of changing what it looks like. I suggest that you put all of these in parentheses. And then we're going to have a big fraction for this one. Okay, so rules of fractions, we just multiply straight across. Look at the top. What does that look like? Distributive. So distribute the 7 into the parentheses. 7 times 3 gives me 21 minus 7 root 5. And then look at the bottom. What does that look like? Foil or box. You can use either method that you want. I'm going to use foil, but box will still give you the same thing. 3 times 3 gives me 9. 3 times negative root 5 gives me negative 3 root 5. Positive root 5 times 3 gives me plus 3 root 5. Do you guys see what's going to happen there? And then square root 5 times negative square root 5 gives me negative square root of 25. So on top, these cannot be combined because 21 does not have a root next to it, so we're going to leave it as 21 minus 7 root 5. And then let's simplify the denominator a little bit. Negative 3 root 5 plus 3 root 5. What does that come out to? 0. They cancel, which is the whole reason why we multiply by the conjugate. When we multiply by the conjugate, it's going to give us one positive term and one negative term. So they'll be able to cancel each other out. And then, so that's going to be 9 minus square root of 25 is 5. So that ends up simplifying even more to 21 minus 7 root 5 over 4.
What did you do just now?
I subtracted 9 minus 5. Sometimes you might be able to simplify. However, remember guys, that this is the same as 21 over 4 minus 7 root 5 over 4. Remember, we can break it up because of those common denominators. So if you're going to simplify, you either have to break it up and simplify individually, or both of them need to simplify by the same number, okay? Once we get to that point, we'll probably end up breaking it up, okay? But as of right now, nothing simplifies, so we're good leaving our answer like this, okay? Example 8. Root 3 over 9 minus root 2. Okay guys, so we have a root in the denominator, so I need to get rid of it. But because it's being added or subtracted, I need to multiply by the conjugate. What would the conjugate of that be? 9 plus root 2. Okay, so like I said, let's stick it in parentheses. This looks like distributive properties, so that's going to give me 9 root 3 plus root 6, right? All over. Did anybody use box instead of foil this time?
I did.
Okay. 9 times 9 gives me 81. Plus 9 root 2. Minus 9 root 2. And then negative root 2 times positive root 2 gives me negative root 4. So that's going to give me 9 root 3 plus root 6. Remember, like I said, roots kind of work as like terms. If this was a 9 root 6 plus root 6, we could combine them. Because what's inside the roots are not the same, we have to leave them separate. So you can only combine roots if the root is exactly the same. And we will do problems like that later. So right now, just know that we have to leave them separate because this is a root 3 and this is a root 6. And that's going to all be over 81 minus 2. So that's 9 root 3 plus root 6, all over 79. Did anybody get that? Good. Okay. Okay, so last thing we're going to do is we're going to be solving using square roots. So this is going to what we did in the academic opener today. So I'm going to be giving you a quadratic with a squared term, and you're going to need to solve using square roots. So step 1, we want to get the squared term by itself. So it's kind of like solving a regular equation. We want to get x by itself. So we want to try and get that squared term by itself. And then, because we always take the opposite to solve, the opposite of a square is taking the square root. So we're going to take the square root of each side. One thing we always want to remember is make sure that our answer is plus or minus. I will show you why in a second. And then a lot of times you'll be able to simplify some more. So make sure that you're simplifying all of the way. I will show you some examples where that happens. Okay, so example 9. We have x squared equals 49. First question we want to ask ourselves is the squared term by itself? Yes, it is. We have x squared by itself equals 49. So that was step 1. Step 2, we want to take the square root of each side. So to undo that squared, we're going to take the square root. Why? What's the square root of x squared? X. So we got x by itself, which is what we want. Now step 3 is mostly a reminder. It says make sure that your answer is plus or minus. So let's put plus or minus as our answer, and I'll show you why in a second. What's the square root of 49? 7. So our answer is going to be plus or minus 7. Why is it plus or minus? Yeah, because 7 squared gives me 49, but negative 7 squared also gives me 49. So we have to list both. So one thing that I always tell my students is if you are the one drawing in the square root, so you're the one taking the square root, you must put plus or minus as your answer always. Okay, so your answer should always come out to plus or minus something. Okay? Example 10, really quickly, we're going to go through this one, and then I have 1.5 more to show you. W squared equals 84. W squared is by itself, so we can go straight to taking the square root. So that's going to give me W equals. Let's break down 84, because this is obviously not a perfect square. So we have plus or minus. 84 breaks down to 21 and 4. That's 3 and 7, 2 and 2. So that's plus or minus 2 squared times 3 times 7. So what's my answer going to be? Plus or minus 2 root 21. Okay, so it's also possible to have a root as your answer. It's not always going to be a perfect square. But you still need to have the plus or minus. That's the purpose of showing you that. This is an example of when the square term is not already by itself. So we have t squared over 20 plus 8. I want to get the squared term by itself, so how would I do that? Just like we've always been doing, subtract 8. So that's going to give me t squared over 20 equals 7. And then t squared is still not by itself, so what do I have to do? Multiply by 20, good. Because those will reduce, and I get t squared equals 140. Now to solve for t, I'm going to take the square root of both sides. So that's going to give me t equals plus or minus. 140 breaks down to 14 and 10. Which is 7 and 2, 5 and 2. So that's going to be plus or minus 2 squared times 5 times 7. So my answer is going to be plus or minus 2 root 35. One more. example 12, x minus 3 squared equals 25. This looks way different, but similar. When we had something in parentheses, what have we done before? Substitute in. So if I let a equal x minus 3, that's going to give me a squared equals 25. Take the square root. So a equals plus or minus 5. But that's not my answer because I need to plug this back in. So that's x minus 3 equals plus or minus 5. Add 3 to both sides. So I get x equals 3 plus or minus 5. Now can I do that? This is actually two different problems. This is 3 plus 5 and 3 minus 5. So I'm going to get two answers, 8 and -2. And that's your answer.